In my previous class, I treated Kirchhoff's current law. In this class, I am going to treat Kirchhoff's voltage law because that's the second law. We have two laws. The first one has been treated in the first class. So in this second class, I'm going to treat Kirchhoff's voltage law. And this voltage law is very simple. According to Gustav R. Kirchhoff, he said that the algebraic sum of the EMFs, and the potential difference or potential drops across each of the resistances is zero. That's what Kirchhoff's voltage law is all about. So if we put that very simple, it means if we have the algebraic sum of the EMFs, let me use the EI to represent the elemental sum of EMFs, and then potential difference, right? PDX, or potential drops, is all equal to what? Zero. This is what Kirchhoff is all about. Voltage law is all about. I repeat, this is what Kirchhoff's voltage law is all about. So if we represent this, we go through a loop. Okay? Okay? Yes, we go through a loop. That means in a closed circuit, if we take A, we take this B, we take C, we take D, and back to A. Alright? So if I should redefine or return the definition of Kirchhoff's law, that's what it means in a closed circuit or in a mesh of circuits, that the algebraic sum of the EMFs and potential drops across the resistances is equal to zero. That's what it means. It must be a closed circuit, so to say. Alright? It must be a closed circuit, so to say. So let's delve into that. What it means, we move this way. If we take a clockwise direction from E2, look at it. This is our direction. If we take this direction, right, it means that this is positive. E2 is positive, right? This is negative because the direction here is opposing our direction, which is clockwise. But this moves anti-clockwise. So this should be negative. Minus I current 1, resistance 1. We move on again to this point. The EMF here is opposing the current coming from this EMF, is opposing the current coming from EMF 2, right? That means that this will be negative, alright? So E1 is also negative. Then we move that again. This is also negative because it's opposing our direction. Our direction is clockwise, but look at it, alright? It's moving this way. The resistance drop, resistance offered, and the potential drop against the direction we have taken is going to be minus I2, right? Let me get chalk, right? Minus I2 R2, good. And then down again, what do we have? We have another one. Another one here is going to be minus as well because it opposes our direction. I3 R3, good. That all these things is equal to zero. That's what Kirchhoff's voltage law is all about. We can rearrange this quickly. We pick E2 and E1, E2 minus E1, all equal to all that baggage. Okay? So what do? We have I1R1 plus I2R2, okay, plus I3, current 3, and the resistance 3. That's all. That's all. We have started this in a very nice way. Okay? That's what it means. Kirchhoff's voltage law. So with this, we have a basic understanding of what Kirchhoff's voltage law is all about. So with this, we can solve some problems. We can analyze certain things. Okay? With that, if we know all this, there's also some analysis we need to do, that E2 minus E1 is equal to I1, current resistance 1, that is current 1 and resistance 1, plus current 2 and resistance 2, right? Okay? We should also take note of this, that current 3 is a split. It's a split of current 1 and 2, because it is only current 1 and 2 that will combine to flow into the junction 3, supposedly. So we will have plus current bracket open current 1 plus current 2 or bracket resistance 3, right? If we understand this, we can also evaluate further by saying minus E1 I1 this plus this, and then we have this. We open the bracket, we have I1 R3 plus I2 and then R3. Good. That's what it means. We continue here with this E2 minus E1. We have I1 R1 plus I2 R2. We are collecting like terms now, right? This is it. I1 can come with this, and we have plus I1 R3 plus I2 and then R3. So further analysis is this minus this is equal to. So we're trying to get that. The next thing we need to do, all I1 brackets, R1 here will go in. There's I1 here, that is plus 3, all right, together. So we take I2 plus all I2, bracket open, R2 plus R3. That is so interesting, right? If you have watched up to this moment, subscribe. Come on, give us some thumbs up. Share with your friends, networks, and students. Put on the bell button for constant notification. Many more of these will come your way. Come on. Learning is very, very interesting. I'm doing this for your learning pleasure, and I want you to gain from it. All right. See you in my next class, where I will be explaining more on the applications of Kirchhoff's voltage law and how it is applied in solving different electrical circuits. In the meantime, I am going to stop here. We'll be looking at application 1, right? Application 1. We're going to look at application 2. We're going to look at application 3. We're going to look at application 4, and so on and so forth. So become a member of this channel by subscribing, giving us some thumbs up, and sharing with your network students and friends. You will learn a lot from this. Any question, any statement, any thought, any idea, put it in the comment section and I will address it. Thank you, and see you in my next class. I will link that video there or there, right? Hoping to see you. Thank you.